Hello, my name is Esteban Osuna, and this is my final presentation for CSE 335, and my application is called WordPal. So, a brief little overview of my project. The project is an application that helps people improve their vocabulary by offering them a quick way to look up words that they don't know. It offers an easy way for people to collect a list of words that are new to them without having to open the internet application and having to look them up on there. The thing that sets us apart is that it gives people a real list that they can look at, and it shows them how many words that they've been adding to their actual vocabulary. It gives them a physical list to see that, oh, over the past 2 weeks, or however long I've had this application, I've added 20, 30 words to my vocabulary, and it just shows them, like, a real benefit of them using this app. The app also offers the users the ability to search local libraries in the hopes that they actually go to those libraries and find some books to read. And as they're reading books, they can hopefully find more words that they don't know and add them to their list of words in this application. This is the class diagram of my application. As you can see, there's a lot of views in this application, meaning there's a lot of pages that my users can actually go to. So there's the main view controller, which just has two buttons, words and find library. And these two buttons just offer links to the other views in the application. So the view controller just acts as a main page as a navigation. If you look to the left, you see the word class, which is the word entity, actually. And the word entity is an entity that is stored in core data. And what that means is simply that this entity and all objects that are created from this, different word entities, for each word that the user looks up with the application, they're saved in the form of this word entity that has the attributes name, which is the actual word itself, the definition, which is the definition of the word, and the part of speech of the word, like noun, adjective, adverb, and stuff like that. So these will be saved in the actual core data of the application. So in the case if you close the application or just tab out of it, or if you actually turn off your phone even, if you open the application up again, all of these words will still be in the actual memory of the application and they will still display in the application. So that's why I used word entities in the form of core data, so that users can always have access to all the words that they actually looked up in the application. The word entity class also has a function fetch request, which just allows the rest of the application to be able to access this entity from the memory of the application, from the core data of the application. So the Find Library button on the view controller links to the map page view controller. And this is the page that allows the user to search a local library to them, or even in another city, wherever they want, actually. So on the map page view controller, there's a map, which is just a map view. There's a text field where the user can enter in either an address or a city name, and then there's also a button, the search button, which when clicked, it does all of the map calculations and logic, as far as like finding latitude and longitude, which is why I have latitude and longitude variables in this view controller. Yeah, the search button does all that, and it displays on the map view annotations in the form of pins, and all of these are they're just little graphics on the map that show where the actual libraries are, and it displays the names of the libraries. So if, say, I entered Tempe into the text field and I click the search button, on the map would be a local map of Tempe, and on the map there would be different pins corresponding to libraries around the Tempe area. So that's all of the map page. The words list view controller page has the actual list of words that the user has looked up. So this has all the words displayed in the form of a table view. So every time a user adds a word, it's stored in the core data, and in the background, the table view is always updating to make sure that all the contents of the core data the word entities and core data are displayed in the map. So as you can see, there's a fetch results array that is an array of word entities, and this is basically just all the words that are stored in the memory of the application, just so that we can use them and manage them all. So as far as functions go, they're all the functions that are necessary for a table view, like number of rows in the section or the cell for row at this certain index. I don't really want to go into too much detail on all of these because they're not really specific for my application. They're just more necessary to actually implement the table view. What I do want to talk about, though, is there's 3 buttons on this view, or this page. There's the Add Word button, which prompts, when clicked, it prompts the user to enter a word, and when they enter this word, this page calls a dictionary API, and this API sends back a response in the form of the JSON data, and the word list view page processes this data and parses through it and stores all the data that we get from the API call, like the definition and the name of the word and the part of speech of the word. It stores all those into a new word entity and adds that entity in the core data. So that's what happens when you click the add word button. It creates a new word entity and stores it into the core data. Then there is the refresh button, which simply just refreshes the table view so that you can see the new words that you added. Then there's the delete all button, which will delete all words from the table view, and also all the words from the core data. So when you click this button, it'll completely wipe everything. So even if you exit the app and come back into it, nothing will be there. There's also the word table view cells, which are just basically a label for each table view cell that has the actual name of the word on it. So each cell will have a different word on it corresponding to the actual word that you searched. So there could be like big, cat, ginormous. All of those will be the labels for each table view cell corresponding to the word. And you can click on one of these cells depending on which word you want to get information about, and it'll take you to the detail view controller. And this has all the information on the word, and it displays all the information that we received from the API call from clicking the Add Word button. So this just displays all the word entity attributes to the user. So the detail view controller will tell people, or the users of the application, the actual word name, the word definition, and the word part of speech. And on this page, the user will also be able to click a button which takes them to the web view controller page. And this is just basically an internet page on another view of the application, and it takes the user to a thesaurus page online, and it just allows the user to enter in a word, or the word that they want to look up synonyms for. And this page also has navigation, forward, backward, and they can navigate back to the detail view controller where it lists all the information about the words. So that's the main class diagram of my application. The MVC diagram just goes over the model view controller architecture of my project. So the view just basically displays buttons and labels and map views and stuff like that. It doesn't really handle any logic or data like the model does. It just basically displays everything that the user is going to be looking at. Then there's the controller, which is actually the logic of the application. So this handles like the retrieval of words, word titles, word definitions, and word parts of speech. The controller also handles the actual API call and the parsing of the JSON data from the API call. And it also stores these, or handles the storage of these into the core data. It doesn't handle the core data itself, but it handles the addition of entities into the core data, the attributes into the entities. This also handles user input to buttons, user input to objects from the view. So if a user clicks a button, the controller will handle that. If they enter text, the controller will handle that. It also handles web view parameters and the local map info, and the local search request itself. And the controller and view interact through user actions and user updates. So if the user updates the word table, that's how the controller and the view interact. If the user updates the map view, the web view, or if the user updates the word page title, the word itself, the definition of the word, or the part of speech label, that's where the controller and the view interact. The controller and the view also interact when there's user action. Like I said, if someone pushes a button, taps all the buttons in the application, like delete, add a button, or search for a library, like entering into a text field, that is also handled by the relationship between the controller and the view. Then there is the model/core data, and this is basically what it says it is. The model handles the actual data stored inside the application. So it handles the word entity itself and all those attributes. It provides the storage for the word name, the definition of the part of speech. It also notifies the controller of any data change for the core data. So if we add a word, that's how it communicates with the controller. It also interacts with the dictionary API, and it offers real-time updates to the core data. So the model really handles the data of the application. And the way the model and the controller interact are by updates and notifications. So if there's an update needed, like we need to save the word, the definition of the part of speech into core data, the controller and the model will communicate to do that. And also if we need to save locations or annotations, that is something the model and the core data will need to communicate on. Also a notification if a word has been updated, a word has been added, deleted, or the table has been refreshed, since they all involve core data, the controller needs to communicate with the model to actually get access to that data. So that is the basic architecture of my application. The capabilities and the limitations of the project. The app itself is actually very easy to use and understand. It's very intuitive. You see a plus sign. That usually means addition of a word. So you click on it, and you add a word that you don't know. As of right now, the user can just add words, delete words, and look up synonyms for the words. The user also has access to a very good map feature to find local libraries. As far as that goes, the application works completely fine. One of the main limitations, though, of the project is that the app only lists one definition for each word. The API that I used sometimes offers a very different definition that we'd be expecting as the first definition. And when I process the API calls, I only use the first definition that the API outputs to me in the form of JSON data. So an example I had was I looked up the word monkey, and it didn't give me the definition that this is an animal, a primate, stuff like that. It gave me a very different definition that I was expecting. It was correct. It was a correct definition, just not what people would be expecting. It's just very different. Not something you would find in the top list of a Merriam-Webster dictionary or something like that. So that was really the main limitation of my project. I would have really liked for the user to be able to cycle through definitions and pick the one that they like, but in the current implementation of this project, they're only offered the first definition that the API returns to me. So if I had the chance, I would like to change that, if I had more time. The lessons I learned were how to successfully call an API and parse through JSON data. In the class, we had labs that covered this, and I didn't really understand it, and I really had to do this for the project because it was a requirement, so I'm really glad that I learned how to do that, and now I feel comfortable with making API calls and actually parsing through JSON data, which I had no experience before this. I also learned how to implement core data with a tree view, which is also something that I found challenging in the labs in the class. I also learned how to debug a project in Xcode, which I thought was very important, the whole debugging process. I did not catch all the bugs, unfortunately, in my project, but I caught as many as I could, and I think this is a good lesson to learn in any programming language and in any environment, how to debug. So I'm really glad I can do that in Xcode and debug Swift code now. I also learned the importance of setting goals and deadlines for myself, and it allowed me to complete this project on time and even ahead of time, which I was really proud of. I created a project I'm proud of, and within the time frame of the deadlines. So it kind of made me be responsible, which is always a good lesson to learn. And I also learned how to fully use a model view controller architecture for a project like this. During the labs, it was really easy to not really adhere to this architecture strictly, but in a big project like this, you need to have this sort of organization. So I really liked how I was forced to use this practice into this project. So that was a really good lesson, and it really helps with the flow of actually creating an application like this. Some suggestions for improvement for the class. I really would have liked to be able to work on the project with a team. I feel like this would allow us to build larger scoped projects. Yes, they would take more time and they would be more complicated, but I think they would be something better that we could showcase. And also we could implement more into the apps themselves if we had more than one person working on them. But I understand why it was a solo project, and I understand that, but I just felt that we could have done more if we worked with other people. I would also like the option to implement more game-type apps, yeah, more like games, actually, instead of just data processing, which is what I chose. We only had one lab that dealt with animation, and I thought it was a shame because that's a very interesting part of the mobile app development subject. So if maybe we had the option to like develop a game, that might have been fun, too. Also, for the project, I would have liked a lot more time to debug the app and think of more features to add to it. It sort of crept up on me, the actual the deadlines that I needed to actually submit my ideas for the app. And maybe this is just me, but a lot of my peers also felt this way, that maybe more time, if we had learned more about it in advance, we might have been able to add more and really think more about our app, which would have been nice. But overall, the project was a really good way to showcase what we learned. I would have never really thought I'd be able to make an app like this. I don't even have an Apple computer, so I'm really impressed and happy that I created a project like this. So thank you for giving me this opportunity, and yeah, that is WordPal, my application.